areas where, you know, things where you run into things over time, you know, like certain things people come up and ask you over time, or things that you just run into enough times that you're like, you know, if somebody had told me about this sooner, it wouldn't be as painful as every time that I keep running into it. Kind of like, you know, going down the basement stairs and realizing that, you know, you probably should have flipped the light switch about 2 steps back. You know, that kind of pain, that sort of thing. And what we have here is a presentation on DNS and Bind. So I'll let you get started, next one.
I'm going to give up on the live presentation. Because that's how it starts. Well, we got slides.
Oh, all right.
We'll do the slides. All right. Can't get called out by the Python guy without, you know, making a quick Perl blog. I'm Mitch. I work for a local IP that provides IP transport and facilities-based internet all over the world, or all over the state of Michigan. One of the large projects that I work on is the route asset database, which holds routes how to get from point A to point B in origin ASS numbers in a central database. It's a pretty neat project. And of course, to find the database, you need DNS. So somehow, completely on accident, I ended up working with our DNS infrastructure for all sorts of organizations, from a guy who wants a quick homepage to completely automated, cloud-based, massive scale systems. One of the fun things that that I get to work on is we're the old legacy registrar for your cc.mi.us and lib.mi.us and k12.mi.us. And I delegate, or part of the team that delegates a little over 1,800 zones to individual organizations. I also host DNS for people to, as of today, just shy of 3,000 zones. These are anything from 1 or 2 A entries in a zone file to massive zone files that run mi.us and similarly large organizations. From davenport.edu to merit.edu, mich.net, redb.net, and a handful of other zones. So one of the things have I mentioned? One of the things that I learned quickly on when I started managing DNS is that WHOIS has absolutely nothing to do with DNS, and it's the first thing that people look at when every machine in the world looks at DNS and not WHOIS. And it'll completely catch you off guard how WHOIS actually works until you dig into it. And then once you start digging into it, you realize that the dig command doesn't exactly do what it says on the label. So I kind of created a fun zone here. You can register a zone at any number of registrars. It's now completely decentralized. Now, if you want to get yourself a .com or .net, you go pay somebody $10 and you've got one. That registrar usually ends up at somebody like name.com or Network Solutions that has an API call into the .com registry, or the .net or the .org or the .us registry. The .com registry is one organization that maintains a massive zone file. That zone file is replicated out to all of the .com TLD servers. And then there's kind of this sad little thing on the side that deals with WHOIS. When you run a WHOIS query, most of the time you see something along these lines that prints out all sorts of information about the organization that's connected, and then it shows the name servers, the authoritative name servers at the top. One little bit of trickery that you probably didn't notice just happened until you go looking is that you're looking at the WHOIS server of your registrar, the person you paid, not the company that operates the zone file. So in this case, this entry came from Two Cows, probably one of the Network Solutions spin-offs, I believe, but I'm not entirely sure. But you actually get the option of, in your WHOIS client, punching in -- no redirect. --no redirect will stop your WHOIS client at that very first server that it's aware of. So your WHOIS client has some concept of what .net is or what .com is, or it's referencing a library that does. And here we have VeriSign's copy of what they think is happening in .net. At least where the key point here is they're telling you who the real WHOIS server is. So when you type a WHOIS, you're going to first bounce up to the VeriSign. If nobody knows, VeriSign runs the .com and the .net zones. There's a handful of companies out there. Neustar runs the .us zone. Americ does much of the mi.us zone. So lots of different zone providers out there. VeriSign does com, net, and edu from a DNS architecture standpoint. So you pop over to WHOIS, you get a very weak record that gives you, then you redirect over to wherever the money ended up. At least where the money ended up the first time. The DNS architecture is completely disjointed from the WHOIS architecture. So the first thing that people tend to do when they're troubleshooting DNS problems is jump in their terminal and type WHOIS, whatever the name of that zone is. And it prints out a couple name servers. Again, these are just what was sent from the API of the company that you paid to the company that's running the TLD. So then we have to start digging into how our machines actually get DNS, because we're probably looking at who has information because there's something wrong. Most machines are configured to talk to their own sub-resolver, at least most high-performance machines. Your Etsy network interfaces or equivalent usually has an entry for 127.0.0.1. You're going to talk to something bind or DNS mask locally, which is going to be configured to talk out to a global DNS recursor service. We're all common with Google's 88888 or the one that your local ISP gives you. OpenDNS seems to be a popular resolver service these days. These resolver services then quickly walk the DNS tree, starting with the root zone, which is the simple dot at the end of the domain name that nobody ever looks at. In fact, most of the time we don't even type it. All of our tools assume that there's a dot at the end of the domain name that you just typed. The root servers then walk you down to the com label. Com dot is a zone, and then the domain name that you've registered. So kind of walk down that tree. So, I realize I was moving backwards. So, when we're asking for a really simple A record, fun test zone tonight because I can actually break DNS. So we're gonna see our WHOIS record disjointed from our DNS record here in just a second. So I made up a zone on mitch.and-arbor.mi.us for the purposes of this presentation. It'll be gone tomorrow morning. I asked for an A record, and the first thing that I get back from Dig is an answer, but I'm also told it's not authoritative. I just talked to my resolver. In this case, I talked to Google. I asked Google my 8.8.8.8 resolver. Got back my IP address exactly what I asked, but that still doesn't answer the question of how did I get that or where did it come from. So then I take the next logical step as a human and I said, give me the name servers for mitch.annarbor.mi.us. And then I see my DNS infrastructure, ns0, 1, and 2.im. But again, back up in the query, I talked to Google. I talked to 8.8.8.8. I didn't talk to an authoritative server, and we see that in the flags that comes back. So we do, there's got to be a tool already built for us to do this, and there is. Dig at NS will let us talk directly to the authoritative name server, assuming you have that knowledge, which we think we do because we talked to DNS, or we talked to Google or our favorite resolvers, DNS. Pretty straightforward. I'm now at least talking to a machine that thinks it's authoritative. But if we didn't follow the chain ourselves, we're not sure this machine should be authoritative. It claims it's authoritative, but we're not sure this machine is really delegated this zone. Dig gives us a really nifty tool to check this out. And this is the first of the hidden gems of Dig. It'll it'll catch you off guard, and somebody might already see it. But all I typed was dig plus trace in the zone that I was after. I started by getting a list of the root servers. These are the dot at the very end of the domain name that we don't normally look at. Dig trace then scrolls down and gives me a list of servers that answer authoritatively for .us. And here we see that we asked a root server we asked a server that's in charge of the dot zone, who's in charge of US dot. And then it gave us back a list of official US servers. Then the next line down on this receive 100 bytes, I'm talking to the US servers asking where can I get Ann Arbor .mi.us, and they say, hey, go talk to Merritt. They know where Ann Arbor.mi.us is. So my dig plus trace continues. It's pretty straightforward, and we talk to another server. Now we're talking to dns1.merit.edu, and we're asking where do we find Mitch.AnnArbor.mi.us. And Mitch.AnnArbor.mi.us is located way over at ns0.im. And finally, we get to the bottom and talk to my name server infrastructure, NS0, 1, 2, and 3, and we're able to ask for the A record. So it gives us this really nifty tool to walk this entire chain. But there's one huge gotcha when we're doing this, is that every time dig itself does one of these queries, even though it's a very capable utility, every time dig walks down the tree, every time it picks one of these answers completely at random, it's going to ask the system library and the system resolvers to get that answer for one of the root servers. So in this case, dig isn't referencing a local hints file to find where the dot servers are, where the root servers are. It's actually going to go back and check whatever the system's configured with. So even though it's fully capable of doing 100% of its own DNS, it short circuits every step of the way. So we start with an A root, or we start with the dot. It simply asks whatever's configured in your system for the dot. Once it asks the system for the dot, it picks one of those completely at random, knowing that it's trying to work toward a Mitch.AnnArbor.us, right? It's working down the chain. Knowing that it's doing that, it asks the system, not itself, it asks the system for the IP address of jrootservers.net, and then asks jrootservers.net for the NS records for .us, and then instead of doing its own lookup, it asks the system for a.cc.tld.us, picking completely at random, and so on and so forth. And the really tricky part of this is this means that the system and its stub resolver and whatever resolver that you're asking can have its own cache of what's going on completely separate from what's actually happening in the world. So the too long didn't read version of the 5-minute presentation was written by somebody much better than me. Plus Trace cheated and consulted the local resolver to obtain the IP address of the next hop name server instead of consulting the glue, meaning that that it didn't try to resolve the entire DNS chain itself. It did one step at a time and asked the system every step. And it will catch you off guard when you're troubleshooting a really tricky DNS problem. So, I can talk about DNS. I've given hours and hours of presentations. So I'll try not to bore anybody unless anybody's got questions. Yeah?
I'm sure I could ask hours and hours of questions.
Yeah.
So I'm in a large organization,
yep,
right? And I don't have access to be able to manage the DNS. I'm just a user of it.
Yep.
But I have all kinds of systems that I'm constantly changing the DNS for, right? I'm constantly creating a new environment, building it something, and reusing old IP addresses and stuff like that. So I'm, fairly confident at figuring out when something breaks because it doesn't work.
Sure.
But troubleshooting it gets kind of difficult I get duplicate IPs when someone, like, I have a virtual machine, someone's turned off for a few weeks, the IP address is used by a different machine, they turn it back on, you know, that type of thing. So I'm really looking for, you know, some guidance, I guess, on how can we manage IP addresses with these tools? I mean, should we be using dig to find out if something is, I'm not just using like a ping. If there's something that responds back, okay, I don't use that IP address, I pick a different one. How can I find out, I guess, you know, that the IP address is really usable again? Is there a way of finding out who the authority is and where that name belongs?
So on a small scale, which this may or may not be, it's kind of right on the level, is we deal with all of that with the reverse DNS. We use the INAT or ORPA zones we have a very strong rule of one host name to one INAT or ORPA address. And we rely on whether there's an entry in the reverse zone to know whether a machine's there or not. So that's the best DNS tool to keep track of IP accounting. Are you familiar with INAT or ORPA zones?
So it sounds like a tool that's available on the public internet, but I'm not sure. But what is it you're...
So it absolutely exists on the public internet. It doesn't have to only exist on the public internet. In order...
Okay, so I can make a private copy in my environment network.
Yep, as long as you have private resolvers. You know, you can't ask Google at 8888 for an answer. But you can maintain that 10-dot zone without a problem.
I think it's good practice to have.
Yeah.
Both forward the A record and the reverse zone.
So the network RFCs strongly encourage for IPv4 that you depends on what agreement of ratified you subscribe to. Say that for every public IP address you should have a reverse record. And if you subscribe personally to one reverse record per IP address, then there's no conflicts at all. And you can consult DNS for the authoritative list of what IP addresses are used for the organization.
Okay, so I'm following 50% of what you're discussing here. That's great. I mean, I'm much further along than I was before I asked the question. So a reverse DNS.
It's the ability to take an IP address and find out the name.
Okay, so I use like NS lookup.
Yep,
right?
so we'll do.
Yeah.
You can use dig minus.
Yeah,
Dig is a newer one, right?
Yeah.
NS lookup is kind of cool, but
Yeah.
sometimes I don't have dig installed on stuff.
Yeah.
So we often use. It's not quite large enough. Right, so we're familiar with using DNS to turn a domain name into an IP address, a forward record, an A record. Here we've got an A record and a quad A record for an IPv6. We can do the exact same thing in reverse. We can use the entire DNS tree to look up a host name by IP address. So I'm maintaining a zone, 117.75.207 zone in my public DNS infrastructure, because this is a public IP address, that has an entry for 71 that returns back the authoritative host name. If you maintain this infrastructure, then whoever's doing the update of these PTR zones can guarantee that they're unique and not used by more than one host. And when you can have obviously multiple A records pointing to a single IP address, but this way you can only have one PTR record pointing to a host name. So this works out very well when you've got virtual hosts, you know, one machine that has 10 names.
Yeah, I have hundreds of virtual machines.
Yep, this tells you what the real machine is. Yeah, if you have one machine, so I was talking about like Apache or Nginx virtual hosts, where Apache or like Nginx virtual host, where you have one machine at one IP address that has 10 real domain names. This helps you find that person, what the name of that real machine is.
Could be a virtual host in Apache.
for fun, we can look at what one of these records looks like. Yeah, sorry for the terrible choice of colors.
That's the default.
But here I go through the effort of creating just a regular zone file and its IP address on the left and host name on the right.
And that's not a line number on the left, that's the.
That's the IP address.
That's the end of the IP address?
Yep.
Or,
Yeah.
technically, the
So go
beginning
down
of the
this-
IP address in reverse.
Go down to 71. There you go.
And you can maintain this at any level of granularity you'd like to, right? You could do 71, I don't even remember what the address is, right? We got DNS for that. But you could do this in one large flat file without any constraints. Depending on how big your IP space is, there's no real limit. I do one zone file per nibble, because it's clean and easy.
Go back to the top of that file. Should have the whole lot. There you go.
So this could be one massive file that's just 10.ini.org or 192.168 or 168.192.ini.org, and you could list every host that's in your network right down the list. So it's a great tool for IP administrators, especially if you're working out of an Excel spreadsheet now, or something along like that. If you're using something, if you're using an IPAM, everything from open source PHP things to Blue Cat or whatever it is that the big guys are using now, they will export these files right to your environment and make them available to your entire organization. Generally, I think it's safe to share every machine name with the entire world. That's why I really don't have any problem sharing with you guys that, hey, here's an SQL machine and a public IP address. My naming convention is not my security.
More questions? So, we often talk about like a name being related to a physical host, right? So, I'm running into a problem where the environment I'm in, the hosts have names that are pegged to the building that I'm in. The naming convention that's been around for years. Well, they're gonna wipe this building. We have to move it. So it looks like I'm gonna have to like change every single name on every single box that I have, right? And I don't want to have to do that again when they move everything the next time, right? So I'm just wondering if there's an interesting way maybe to get around, having an environment that just is picked up and moved somewhere else.
Yeah. So the best way to do that is, or at least the way we attack it, is with a name for the service. So www dot is the name of the service, or whois dot is the name of the service, and that's independent of the machine that's actually running it. And a great example of that would be whois.radb.net. This is a machine that I run, it's a service, it's what other machines access, and everybody references it by whois.radb.net. That's what I publish. That's what my machine config files know. That's what customers, internal and external, know. And then my actual name of the machine is something specific to the environment, right? Naming scheme that means something to the person who built this VM. radb-rpslo1.merit.edu. Completely separate zone in this case. And you can use either CNAME records or maintain A records twice to find them. You could also use CNAME records in the reverse to help you in your move. It wouldn't be the resolution, but you could rename the box, give that box a new A record, and then create a CNAME record for the old name to point it to the new name. And this way, any human who does a lookup will be able to tell that the name of the device changed. any service that's still, any configuration, any machine that's using the old name can continue to churn along without a problem.
I like that. It will, I mean, so I still have to move things and rename stuff.
Yep.
But having like an arbitrary name that is not related to the physicals
Yep.
would help out a lot. Yeah.
Yep, and in your case, if I was walking into that, I'd go 3 levels deep. I'd pick the name of the service that this service is always gonna have. I would CNAME that to the new name of the machine. Then I'd take the old name of the machine and I'd CNAME it to the name of the service. That way the machine can move. It can still be referenced by its old name, which is a unique constraint of your environment. And all new configurations will be using the new name. This gets really fun when you're working at a large scale, if you're at multiple sites, and you can control what the resolvers provide via split horizon, or you can control what answers resolvers get by having one service name with 2 machine names, or with 2 machine names and 2 IP addresses. I run a service at a Southfield data center and a Grand Rapids data center. It has the exact same machine name according to all of my configurations at both sites. DNS gives it a different IP address at both sites, so it's hitting the local copy, which is kind of another fun use of DNS. And you can kind of keep going on with fun uses. As many as you want. This is a really simple example of a service name, login.itd.umich.edu, that spits out the name of 4 IP addresses. Your local DNS resolver will pick one of those at random. It's cheap load balancing and costs you absolutely nothing other than running 4 machines, which is kind of fun. This is a case where, on the way of getting there, they're sending you to a specific organization. There's a generic service name, login.itd.umich.edu, where we've agreed that service name will never change. It's what's published, it's what's known, it's what's in machine config files. We give it a CNAME of login.dcs.umich.edu, which is where it currently lives. And then that login.dcs.umich.edu has 4A records, so your machine can pick one of 4. Depending on how detailed you want to get with your DNS configuration, you can do very cheap load balancing by removing one of these IP addresses. I suspect that this has a low TTL of hours. A few minutes. It gives you TTLs in seconds. So these machines will expire out of DNS. Anytime there's a DNS change, we can drop one of these machines and I can force new traffic to go to one of the 3 machines. So DNS is incredibly powerful. Yeah?
So let me, I'm expecting to say, no, there's no way to do this. If I have IP addresses that are home to specific boxes, and I want to move that to another physical network, I have to re-home that with a different IP address. Or is there any way I can maintain the old IP address? Even though,
You got a routing issue.
Yeah, there's two ways to address that. There's my route guys are pretty cool, and they're going to put /32 routes in their routing table to send that routed IP address to the new box. If you've got a fully converged route table, your network guys can point. There's no rule that says that a /24 has to be available in the same place across your entire organization. Your route table can go down to a single host. So they could put a route.
So I can do like a virtual LAN in a different physical location, even though the IP addresses are not appropriate for it, right?
So it wouldn't be virtual LAN, it would be a real route in your corporate route table. And yeah, your network engineers will probably shake their fists wondering why the heck you requested such a crazy configuration.
Yeah, I like it when they shake.
But especially if you can get them down to a small group, right? If you can get it down to a /26 and ask them to move a /26 to a new location, that's very reasonable. The one that you have completely in control of as an Linux administrator are things like hairpin NAT. Hairpin NAT, you can configure NAT to hairpin in, right, accept connections on the old physical box and send them across the network to the new box. Hairpin NAT 1-to-1 is a popular way of moving a physical box without actually moving a physical box, so long as the old one's there for a while.
Yeah, well, they're wiping a building, so I doubt they'll have,
Okay.
the box still there.
Yep. So they'd have to. So then your only option would be to have them move the IP addresses to that location, which is incredibly reasonable when you're a network guy. When you work with people who control the network, it's something we do all day long. One of the neat services that we do is if we have a problem with a web box, or even one of our customers has a problem with their web machine, we'll put a /32 in our global routing table and bring the /32, right, that one machine, to our data center and be the web server for them for just a brief period of time. Which is kind of a neat way to have an emergency failover, right? Something bad happened to that web server, you want your home page to stay up, route it to a different data center. When you're in control of the network, you can do these things. But DNS, get the machine name straightened out, keep the TTL short, and you can rename things a few times. Before you start the DNS change, though, set your TTLs down to like a minute, because why not? There's no reason for your TTL to be longer than a couple seconds.
I feel like I'm dominating the thing, but this is very close to a lot of the problems I'm having every day, right?
Yeah.
So we have network support people who are, they're busy, right? We'll say it kindly, they're busy, they're not responding to my requests, right? So I want to be able to like update the domain name for an IP address.
Okay.
And I've noticed in some operating system version, like a certain version of Windows server, when I put in the no host name, it updates some of that information. Is that correct, or am I seeing something that doesn't really do what I think it's doing?
So, welcome to AD, and scratch your head. Yes, if you are actually, if AD is somehow involved in your authoritative DNS, even if it's writing to a normal DNS system, yes, AD has the concept of writing forward and reverse DNS fragments for you.
Active Directory.
Yes, Active Directory. I insist on only ever getting AXFR or IXFR standard DNS in and out of Active Directory. Never dove into how Active Directory actually does its bits. But it does, yes. Yes, Active Directory does things.
Surprise.
Yeah. Yep. So, hours and hours. Anyway, if anybody ever wants to just chit chat about
You know
things,
what?
yeah.
An hour's presentation may be in the cards.
Yeah.
Over here.
So, I was going to toss the hat in there for DNS conversations. Totally game, but I need scope because
Right, exactly.
it's huge.
You mentioned techniques and circumstances. Is there a tool that is available as an alternative to Dig that incorporates those already into them?
Oh, that's a good question. No, but depending on how little sleep I get tonight, maybe there will be one. That's funny. That's funny. Once I figured out what it was, so the aha moment for me was I kept hitting WHOIS, right? Because I made a change in DNS, and WHOIS is where you go to look at it. And someone finally said, "Hey, I don't care what WHOIS says. Let's go look at DNS." So that was my aha moment. And then of course I had to understand what the tools I were using was doing, right? Because I can't have egg on my face twice. So I learned the limitations of Dig and then continued to use them. So my exploration hasn't gone any further. But it's a pretty simple problem to tackle. I think the last item in the Dig's man page is when it lists known bugs and known issues, there's one line and there's too many options. Digs, too many options. Dig's already grown quite.
That plus trace one is very, very useful.
Yeah, plus trace is,
Yeah. It's a new one for me.
yep, as long as you don't know, as long as you don't trust what it says on the label.
One other question, may, if you don't answer, don't. Okay. NTP, they ask you not to go to the top level sources on that, just because if everybody did, it would, the system would be saturated. Okay. Similarly, if everybody used the original distributed database, would that also saturate the system, or is there some mechanism to prevent that?
Yep.
That doesn't exist in NTP.
Different problems. The NTP problem is really interesting, in that when you say the root of NTP, you probably mean the Stratum 1 servers listed by the Open NTP project.
Or
The NTP pool
Or those
project.
set by ICAO and ITU-D.
Yep, they're not, there is no authority, there is no central, there is no top level. There are simply real cool organizations with really neat clacks that choose to offer Stratum 1 service. There's a few people who maintain small databases of these, the most popular being the NTP pool project. When they say don't go to the top level, they really mean don't put this on all of your client machines and your printers, because your printer probably doesn't need program time for her host to work. So then there's a bunch of other people like me who don't have a really fancy clock, and they contributed a Linux node to, you know, the pool.us. Is it us.pool.nt? I don't even remember the name of the thing anymore. So the whole point is that they tried to solve the NTP problem with DNS by shoving a bunch of IP addresses and returning random Stratum 2 or Stratum 3 servers. So the DNS root problem is completely different, and I would encourage everybody in this room to run their own resolver. There's no reason to trust Comcast or Google or anyone else to give you a good answer when you can do the resolution on your own. You can do it on your own machine. You'll quickly run into Wi-Fi providers that block at least TCP port 53. If your network guys or your firewall guys are blocking TCP port 53, you have problems and you don't even know it, and you're left with your head scratching. TCP 53 and UDP 53 are both valid ports to move DNS queries across. So the root system, the root zone file is really small. It's one, by comparative of everything else, it's one record, one record for every TLD that lists roughly 3 to 7 name servers for every TLD. Those TLD operators, VeriSign being Netcom and EDU, then are responsible for responding to those 7 IP addresses the same way across the world. And the way they deal with that, because your machine picks one at random, they place hundreds of copies of these 7 machines, hundreds of machines that answer for these 7 IP addresses all over the globe. The closest one to you via routing is what gets it there. I personally think that VeriSign can handle a little bit more traffic for ComNet and EDU. All of the authoritative folks, so by the time you go down to that tree and you get to my infrastructure that runs basejp.com or Merit's infrastructure that runs merit.edu, that traffic is known, your local machine caches it, DNS queries are tiny, and if people start doing this one at a time, it's going to be a nice steady ramp up of traffic. These machines are relatively quick and fast because latency is important. They're almost always behind some sort of DDoS protection service. They have huge bandwidth pipes because the first thing that people attack is DNS. So there's plenty of bandwidth available for everybody in the world. As long as we don't all go turn it on tomorrow, If this room does, it'd be a great thing. You all should. But if everyone in the world, including our cell phone manufacturers, kind of do it one at a time, it would be just fine. That said, somebody from Apple probably is going to hear this and push it out in iOS next. Crash the internet.
So how do you go about running your own resolver?
So Bind is the reference implementation. apt-get install bind gives you a completely working package as long as you have port 50, as long as you've got a static IP address, I'm sorry, running your own resolver. I jumped right into authoritative, I'm sorry. So you have to pick a package. It can be Bind. I'm a huge fan of Power DNS, DNS mask. You install the service, launch it on your system, and configure it for stub resolving. Would be kind of your first step to make sure everything's working. Make sure that you can accept a query locally, and you can hand that query off to a resolver who can follow that whole chain. Once you know stub resolver is working, once you know you have your traffic pointed at your resolver, then you can remove that stub resolving configuration and request recursion. Depending on what version of the software you're looking at, there's different binary distributions. Power DNS has a separate binary for their recursor than they do for their authoritative. Depending on your Linux system, Bind will either configure by default with recursion disabled or enabled, so you kind of have to look at what's going on in your particular packaging system.
And then you just point your DNS.
You point your business at localhost, and localhost will take it from there. The important part there is you want to make sure you have an IP tables rule that prevents anything else from querying your resolver. If you run your own resolver, you want to make sure that you're the only one that's going to use it. But I've got awesome guides that can post to the list after.
So I've run out of IP addresses.
Okay?
You know, the building network guys claim that they don't have IP addresses. Of course they do, right? But I'm looking at is there some way I can take IP addresses and somehow address a lot of machines? How do I want to say this? I've heard of something called 802.1q or something like that, tagging the traffic, right? So if I have a system, like a desktop, that needs to connect up to a virtual machine, right? I'm not using a lot of IP addresses to do that.
Okay.
So does that make sense? That how can I use only a few hundred IP addresses to address several more, a quantity more of virtual machines?
Yep. The default is NAT and PAT, network address translation and port address translation. You can then start getting into VRFs if you really need them to create separate logical buckets of IP addresses, but then you're just using more internal IP addresses. VRFs let you use the same group of internal addresses more than once. Kind of like a VLAN. It's a VLAN, but it's available on the routing table, which is where that tagging comes into play.
Okay, so a desktop that wants to reach one of those virtual machines somehow has a route that it can find to get to that one, and then the a desktop next to it or whatever is taking a different route? Is that?
Yeah, it gets really close to implementation specific at that time. It would be more you'd have two groups of people with two separate routes to two different machines if you need to start duplicating IP addresses. But I think really what you're probably looking for is a local NAT or a local PAT device that takes one of your building IP addresses and then gives every device underneath it a private IP address.
Yes, right.
Private again.
So how is it that the desktop would, it's on one side of that NAT, know where to go?
Yeah, so this is the same thing your home router does, right? The virtual machines have static known IP addresses that are shared by everybody. They don't change. They don't sit behind NAT. So your desktop makes its connection through the gateway, right? That's default gateway. The gateway is changing the desktop's IP address temporarily, and hands it off to the server just as everything always is. So desktop.
The gateway keeps track of
the gateway
who
keeps
did
track
it.
of which desktop initiated which query and which connection. You know, the common open source ones, want to bash open source projects, but there's lots of them out there. pfSense is popular. There's all sorts of better versions to do this. I'm a fan of BIOS, or if you must use one of the pfSense forks, there's OpenSense. But this is really common and really simple for the network guys to set up if they're out of IP addresses in one office space. Moving desktops and making that NAT space bigger, or putting a NAT in front of an existing private IP addresses is completely fine.
How's this applied to IPv6?
How does DNS apply to IPv6? Exactly the same way, nothing changes.
Well, but for instance, avoiding running out of IP addresses, either locally or cutting down on the amount of hops you'd have to make to get your resolver and accurate address, an authoritative address.
So there's actually an insane number of potential hops in IPv6.
Yeah.
Every single byte has a point in between it instead of nice little nibble boundaries. The first part is about kind of networking things, and it was how do you make sure you don't run out of IP addresses. I think
IPv6 is enough that if somebody does that for a company, they're not going to run out of IP addresses every time.
No, and nobody, if anybody does any level of reasonable networks address planning, they won't have a problem. I think the recommendation on the table right now is to have a /64 available to every point-to-point link and every local net. So your small office would have every what we consider a VLAN now, even if it remains a VLAN in IPv6 land, will have a /64, which is some mind-boggling number of IP addresses. So even if you have two routers sitting next to each other and you're creating a point-to-point link between them and putting a static route between them, the recommendation on the table right now is to assign that a /64 and then configure it as a /127. But the DNS continues to work just the same way it always has. Nothing changes in DNS land. The only acceptable DNS change from someone who's been a strict RFC follower for DNS has had a reverse IP entry, a reverse entry for every IP address that has a host. If there's a host there that answers, in IPv4 land, whether it's a client or a server, there was no distinction at the time. It has a host name. Sometimes that host name is just, client 67 or DHCP 91 or whatever .comcast.com or whatever it is that Comcast chooses to use for that. In IPv6, the standard accepted practice is only PTR records, only reverse records for servers, for things that have persistent, non-changing IPv6 addresses that will answer forever.
I think we're going to have to cut it off at this point. I think we definitely have at least one, if not two more presentations that we have.
Yeah.
Depending on how things go, I might bore you guys with RADB.
With what?
Which is kind of fun. RADB. It's a route asset database. It's my day project that contains mapping of prefixes to origin ASNs that allow for automatic configurations and filtering at the BGP level.
Wow.
Yeah, very cool. Thank you.
Thank you.
Before you leave,